Hi, welcome to Atlassian Tech TV. Firstly, if you're a subscriber, thank you. You'll be familiar with our series of interviews taking you inside Atlassian and showing you how we make software. But the vision for Atlassian Tech TV has always been larger than that. For something quite different, this episode, I take you to South by Southwest, a festival in Austin, Texas that takes place each year with over 72,000 people attending. I was fortunate enough to be accepted to speak on a technology topic that's both near to my heart and also something that I think is a pivotal technology for software developers in the 21st century. You might have heard of Bitcoin, and if you've read beyond the headlines, you may also have heard of the blockchain. If you haven't read beyond the headlines and you're a software developer, you should definitely watch this. So this time on Atlassian Tech TV, I present in its entirety my talk on Bitcoin, blockchains, the next app platform, recorded live at South by Southwest Interactive. Okay. Hello everyone. Can you hear me? All right, cool. My name's Chris Mountford. I'm a developer from a company called Atlassian. It started in Australia, and that's where I work. This is not an ad for Atlassian, but I'm very grateful for them to send me here, my first trip to Austin. And I'm here to talk about blockchains, Bitcoin, blockchains, which I'm sure you've all heard of. Let me just quickly ask, who has heard of Bitcoin? Hands up. That's good. That's everyone. Everyone's in the right talk. And blockchains, or the blockchain, slightly less. In some ways, we can think of these as aliases for the same thing. I'm okay with blurring some of the terminology. And if you would like to follow me or tweet to me at BlockZombie, which is my sort of Bitcoin-loving persona, I will award you with a Why Bitcoin magazine or maybe some stickers for HipChat, which is an Atlassian chat product. A little bit about me, since you won't know me. As I said, I work in Atlassian, but in my spare time and also some of my work time, I really look at technologies like the Bitcoin blockchain and other blockchains, and I've been involved in a lot of media, national newspapers, and a federal Senate committee hearing on digital currencies that occurred in Australia, and also a number of conferences, including Stanford blockchain workshops at Stanford University. So what do I mean by an application platform? I think we can go through this pretty quickly. We had early computers that were mass market products that people built applications, games, business software on, and as well as the computers themselves, the software platforms, the operating systems, those are platforms on which people build applications. And consoles, games consoles, of course, smartphones, but even also a web browser, and Facebook, and other sorts of platforms, software, social network platforms. And of course, anyone who's an application developer will probably have heard of Amazon Web Services. That is also an example of a kind of application platform. But in some ways, what we're talking about is the internet is the platform. And in today's world, it's so obvious we don't even say that. Everything is internet connected, and so that is the platform. But the internet's been missing a major component for the last, well, until I'd say the invention of Bitcoin, a major component, like a half of it has been missing. And that's the blockchain. So it's that significant, in my view, on a technical basis, in terms of what it can provide. So what can it provide? If you're an application developer or you're involved in conceiving or considering applications, here are some fancy words that tell you the sorts of things that you might be able to build up with software using technologies like the blockchain. And you'll notice that this is a list that's quite different to the sorts of things that you were able to do with pre-blockchain technologies, even on the internet. It covers a lot of stuff that I, as a software developer, someone who's been programming since I was 8 years old, assumed, perhaps like all of you, that software would never be able to do. There's some of these things may need an explanation, but digital identity, authenticity, the idea of something being authentic almost seems to go against the idea of digital, which can infinitely reproduce things. Transactions, maybe, but different kinds of transactions, and I'll get into that in more detail. Financial instruments, well, they're pretty digital these days, but are they really software defined? Well, now they can be. But let me boil that list down for you. The first fundamental that you get from blockchains is digital scarcity. And like I said, scarcity is something that digital has been an anathema to in much of its history. Digital value and what I would like to call digital authority, although I think that word is slightly slippery. I don't mean the kind of authority of a kind of military authority. What I mean is the kind of authority of an author or someone who is really the voice of truth on a topic. So introducing this topic, just these new features for application developers and designers, we're talking about trust computing or trusted computing, which is not just a realm for the post-Snowden era dystopia of kind of paranoid conspiracy theories. You don't have to be paranoid. But actually what I'm really talking about is computing trust. So the production of trustworthiness, of entrusting a system, of trust itself, which is another slippery word, but doing it with computation. So you're creating trustworthiness with software. And that's something that is definitely a 21st century concept. So you don't have to be paranoid, but I think we're still at the stage where a lot of these applications might really be for people who are, and I mentioned marginal activity on that previous slide, which is a way of saying things that maybe the majority or the government or whoever authorities may not really like or may have strict rules about, and so obviously you have to tread carefully, but it's an international internet, and those rules may vary from jurisdiction to jurisdiction. First thing I really want to say about the status of the platforms that I'm talking about is that they're not even beta. They're very early stage, and you can't just run straight in and think that you've got a mature ecosystem to play with. But it is a stack. It's a stack like you may be familiar with here, an application stack. Hands up if anyone's heard of either of these. Okay, looks like about half. So LAMP is just an acronym for Linux, Apache, MySQL, and depending on who you are, either Python or PHP or something like that. And what it means is you're going to take these major ingredients and you're going to bake the cake that is your application using those ingredients. Mean is one I heard of recently, getting in on the four-letter acronym thing with MongoDB, Express, Angular, and Node. It just happens to be a different set of ingredients. You'll also notice that if you understand what these parts are, that they're really at different levels of abstraction, and it's probably best if we put them like that. So Linux, which is an operating system, doesn't appear in the mean stack. Maybe it's assumed, maybe it's not Linux, maybe it doesn't matter. So application stacks can operate at different levels of abstraction. So who's with me so far? I should probably have asked, okay, that's not enough, all right? So we're talking about prefab components for making software, all right? Put your hand up if you're not at all an application developer. Welcome, good. I'm glad you're here because there wasn't enough blockchain material in this South by Southwest, I don't think. But I'm going to dive briefly into some technical things, but I will come back up for air for you so that we can continue. And hopefully the whole thing makes sense, even without going down to every byte. But the point is that you have a stack, like a stack of blocks, which is things are built on top of each other. So what's the application stack for blockchains? Well, P2P, meaning peer-to-peer, is pretty much the core of what we have with blockchains. It's a distributed technology, and it means that peers on the network, edges on the network, nodes they might also be called, connect to each other, and it's not in a centrally managed configuration. It's not like a star or a hub and spokes shape. It may be appear quite disorderly. And on top of the peer-to-peer layer, you have a set of cryptographic technologies. And cryptography, which is the cool sort of thing that drives most of the plots in spy movies, is also particularly good at providing strong building blocks in this stack. And the blockchain comes on top of that. What's the blockchain? It's really a database that you can only write to, typically, and which has a strong, you can probably wait for the culmination of this if you want to take a photo. You can see where I'm going. The blockchain is where all of the transactions are written. It's a chain of blocks, much like a ledger is a book of pages. So transactions themselves, we'll get to them, but those are actually built from software. They are software. They are not just Johnny owes Mary 10 Bitcoin, although they can often be rendered in that way. Really, they're much more sophisticated and capable than that. They're more like something that they are a program. They contain logic. They contain the building blocks themselves, and I will show you those building blocks. So what you have when you have that script on top of the blockchain, you have a platform. You can build things on top of that, and those are your apps. So you can build apps on that platform. But also, and this is relevant to a company like Atlassian, we develop tools for teams. And one of our traditional markets is software development teams. So we have certainly, as part of that application ecosystem, we have tools being developed. And of course, these applications form services. So you can build services from applications, and applications provide services to users. And one thing that's really important is that platform layer is something that can easily be connected to. Easily is probably a word I use slightly too easily. But the idea is that we should expect that platform layer connects to other things that are not part of this blockchain stack, just like applications do today. They reach beyond their stack and they talk to each other. And so that can reach to anything else. Okay, this is your photo op. And that star is where you're going to make something else, and that may be connect to the blockchain, or your app may be running on the blockchain, or it may have a component which does. But which blockchain? You might have heard, if you've heard of Ethereum, and if you're looking at the Bitcoin-related news, you've definitely heard of Ethereum. Who has heard of Ethereum, actually? Yeah. Anyone bought any? How long ago did you buy it? It's been going crazy. So Bitcoin has a blockchain. Ethereum has a blockchain. There's another one I quite like called BitShares, which is modeled more of a, rather than a currency like Bitcoin was originally, it's like a share model, an equity model for a business. So entities are businesses, and you can invest in them. I think these projects tread very carefully with their language these days, because saying words like that actually attracts the interest of particular regulatory bodies, and so some of them have erased their terms and now say that you're buying a product, a token or something. But really that was the original model of BitShares. And of course you can make your own blockchain, and plenty of people do. There are thousands of cryptocurrencies where people have decided to make their own. Most of them are copycats, and most of them are not worth anything. Bitcoin, though, has on top of it built, not the Bitcoin group have not built this, but other groups have built on top of Bitcoin. Because it's the biggest network, it is one in particular is Counterparty that has built protocols on top of Bitcoin. So that provides additional things that were not originally provided in the Bitcoin's blockchain model. But Bitcoin is the granddaddy blockchain. It is by far the most significant one and the most important one. Even if you only look at market cap of the total number of coins, and I would say that's the most shallow way to evaluate these things. But what is the Bitcoin blockchain? Well, it's an unforgeable record. It has a distributed storage, which means that nobody can go and blow up one computer and then erase the whole thing because everyone has a copy. And a block is, as I said, made up of transactions. And these are validated transactions, that they make sense, that they don't conflict with each other or with earlier transactions every 10 minutes. And in a monetary sense, the conflict we were really talking about is somebody trying to spend that same money in two different directions to two different counterparties. That is the purpose of the mining. If you've heard of mining, it should really be called auditing, because it is an operation which checks the validity of the transactions for a fee. And the transactions are signed messages, they're scripts, as I said. The message content is code, and these are broadcast on that peer-to-peer network. And what features do you get from the Bitcoin blockchain? Well, the security of these transactions is very high. Nobody can erase or undo those transactions, and you don't really need to rely on any one group to ensure that the integrity remains. There are little caveats throughout almost everything I'm saying, but there are technical matters, and I'm happy to take questions on them. The security is provided by a process called proof of work. And if this sounds absurd, I'm sorry, it is absurd, but it happens to be particularly effective at maintaining that security. And what it really means is that there isn't a significant and prohibitive cost to anyone pursuing the idea of undoing or unraveling or rewriting that transaction history. And that cost comes with a very hard edge that nobody, even well-resourced companies and governments, really feasibly could attempt. It has a network hash rate, which is one of the significant technical attributes or sort of numbers to watch. That is the total amount of work that has to be proved, if I can continue to use that slippery term. And it has a market cap, which is the total value of all of the coins that are in existence, if you want to think of them as coins. One thing it has, which I really try to emphasize, especially in a topic like this, is that it is completely generic. It actually, well, not completely generic, it's quite generic. You don't need to just be doing financial transactions, and I'll get into that in a lot more detail. So it is a general purpose technology. It has some limitations inside the transaction scripts, in that for the computer science educated people, that scripting programming language that transactions are made from, that is not Turing complete. And that means that there are some limitations on what can be achieved in a transaction. It has some fundamental limits to what can be done. It's really bad at storing data, large amounts of data. Little amounts of data, it's fine. And by little, I mean smaller than an image, actually really quite small. But that's not a big problem, and there are other solutions to that. Another thing to note is it's not encrypted. Although we talk about cryptography and cryptographic features, the content of the Bitcoin blockchain is open for anyone to read. Unless some encryption has been applied to the data that is then put into it, and there are severe limits on the practical ability for people to do that, then anyone can read the content of the blockchain, and so this is a concern for people who worry about privacy. I should also add it's not really anonymous. Little asterisks on all of this. A Bitcoin transaction is composed of three things: inputs, outputs, and lock time. I won't go into lock time, but it's just like a time delay feature that enables transactions to only be valid at a certain time, perhaps in the future. The inputs really are the resources that are being transacted. So in the case of Bitcoin, they all ultimately become a piece of Bitcoin value. Those balances start from somewhere and end up somewhere, and we call those somewheres addresses. So the inputs to a transaction are one or more sources of those funds. And I'll skip through some of this detail, but the outputs are really where those funds go. So you could have, in a poker game, for example, everyone's playing poker, lots of people put their money in to play, and then at the end, maybe 2 or 3 people take money out. So there's multiple inputs and multiple outputs, and that whole game was one transaction. And Bitcoin transactions are code. This is like the central point of this talk. Here on the right are some of the opcodes and the categories they belong in on the left. And if you're a low-level programmer, if you've ever done any assembly, or if you've done that sort of what we would call low-level programming, you might be familiar with what some of these things mean. If you've ever done any maths, you might know what less than means. Maybe you know what 1 and numbers like up 75 are. These are just examples of the sorts of things that Bitcoin scripts can carry. So numbers, numeric operations, logical operations, adding, dividing, checking the size of something, and also cryptographic operations that are specific to the technologies that Bitcoin provides. So things that check signatures are valid. These signatures are all digital, and also the hashes, the cryptographic hashes that I will get into in more detail. There are also these things called no-ops, and those are actually just, they don't do anything. They're reserved for later in case they need to update the ability of the script to do new things. So what kind of programming are we talking about? Well, what we're really talking about is something it's not that fancy and new and fast and sparkly. It really is much more like a 1970s era programming language, like Forth, which is it's horrible and wonderful, but horrible. And this is not supposed to mean anything to anyone. I don't even know what it does, but it's a stack-based programming language which provides a certain simplicity, and it also means that transactions have a huge sort of ability to do any kind of thing that those primitives allow you to build up. So it's a little bit like a box of Lego as opposed to a pre-made toy. And there are three Bitcoin script capabilities I want to discuss. You can pay to a public key hash. What that really means, that's just a normal transaction. That is, I pay to you, or to three of you, or something like that. Or more likely, you pay to me. And number two is pay to script hash. This is fancy. This is actually pay to anyone who can present a script, a program, which will exit, which will finish and give the right result. And if you take the text of that program and compute the hash, and I will explain this in a moment, if you get the hash from that program, it has to be equal to this thing. So you really know that only one program is the one that can actually claim the funds and then control those funds on the next transaction. And you can also do, one thing is you can store some data in the blockchain, metadata, with this opcode called op-return. All those opcodes have just op in front. That's how they write them. So you know that it's talking about an opcode. So what do I mean by this hash thing? Who knows what a cryptographic hash function is? Put your hand up if you know what it is. Actually, let me ask the opposite. Put your hand up if you don't know what it is. And I wouldn't expect, okay, good. So there's plenty of people who don't know what it is. What it really is a, it's fundamental to Bitcoin. Bitcoin can't work without it, and neither can many of our security technologies. It's not encryption. It's actually a kind of one-way function. Now, who knows what this is? A shadow sculpture. Have you ever seen one of these? It's like, this particular one is a kind of like a pile of junk and a light shining on that junk. And the shadow cast by the carefully, artistically arranged junk happens to be, in this case, it's a silhouette of a person. And you wouldn't expect to see that on the left if you just looked, perhaps from the wrong angle, at this pile of junk. And the relationship between the junk and the shadow is the same as the relationship between, or similar to the relationship between some stuff, let's say data, and a hash, is like the shadow cast by that data. So if you've got the shadow, you can't reconstruct the thing. There's lost information. It's a 2D flat picture from a much more complicated and detailed thing. But in the case of cryptographic hashes, it's one way. It's a one-way function. You cannot go from the hash value, which typically looks like a big garble of text, back to the thing that it's a hash of. So the thing that's casting that shadow. And cryptographic hashes are the secret sauce of Bitcoin and blockchains. They're used for everything. Just like my 12-year-old and tomato ketchup on everything. And I will go through this part very quickly because it is quite technical, and I just want to go through it quickly so that you can ask me questions about this, but developers can just go straight into all of the detail. They can see how this works. It's open source software. And the input script for a pay to pub key, this is the normal, not the fancy one, is typically just has the signature and the public key. And I'll show you what they look like in a moment. And the output script, this is the program, op-dupe, which has a hex value of hex 76, followed by op-hash160, which is a hex value of A9. Hexadecimal is just a more compact and convenient way of writing numbers instead of writing the decimal, which is 127 or whatever it would be. And then here's a public key hash. That's the hash of a public key. And then op equal verify, which says does the input that came from this other thing equal this particular number. That's what that part of the program does. And if it does, then, and it checks that the signature is valid, then thumbs up, that transaction is valid, and the money will move. So that's that input script, that signature script. These are the bytes that you would use, and this is for a particular transaction. This is how it works underneath. There's the public key down the bottom, which is just a massive number. And this is a DER encoded script. Some of those numbers refer to the expected length of the following bytes. But let's skip through all that. That's boring. R value, S value. This one, more complicated. This is the fancy thing. This is the, I want to make it so that a transaction happens, but that somebody has to present a program which has the right shadow, has the right hash, and only that program is permitted to move the funds. And in this case, what this does, on the right-hand side, you'll see I have signature A, signature C. What this indicates is that it's a 2 of 3 multi-sig transaction. So this is a little bit like a shared corporate account or something. There are a number of signatories to a transaction. They can make a transaction, but they only need 2 of the possible 3 people to agree, and then that transaction is valid. This program is a script which happens to have the correct hash, and it says any of these, well, 2 of these, see the 2, and then there's 3. So 2 of the 3 keys must be present, and they must be valid signatures in order to enable this transaction to go ahead. So that's what that script does. But that script's hash has been put in the script pub key, which means that only this script and no other script can be the one to actually authorize the transaction. So put those 2 things together, and you can make a. This is a very simple program. It just says any 2 of the 3 people can authorize this transaction. That op hash, you don't want to know about that. And this is the third thing, the way to store metadata with op return. Op return is the operation that's happening there, and then here's just some data. And that's just 80 bytes of data. That can be any data, and I'll show you an example of what kind of data people would stick in the Bitcoin blockchain, why they would do it, and what that gives them. There's another way to put data in the Bitcoin blockchain, and it's frowned upon, because that is only 80 bytes that you can use with op return. And that is, you can use the values of the multi-sig hashes that were, in that case, really different people's signatures or different accounts' signatures. And you can say, yeah, they've got to be equal to this, but actually that just happens to be your data. So there is a way to use what's called bare multi-sig, but it makes the core developers sad, so don't do it. But Counterparty, which I mentioned before, which is built on top of the Bitcoin blockchain, uses Bitcoin transactions as sort of like a publishing and time-stamping service. And there are lots of websites that show you the content of the blockchain. You don't have to download all the, whatever it is, 30 gigs of blockchain to have a look at it yourself. You can just trust this website to show you the true blockchain. One that people always used in the old days was blockchain.info, but if you want to see Counterparty transactions, you should use BlockScan. And Counterparty uses bare multisig, frowned upon, or op return to store their metadata. And what's the Counterparty protocol give you? Now there's many of these. Counterparty's only one. I'm giving you an example. There's another one called Omni. It used to be called Mastercoin. There's colored coins people might know of. And there are multiple of these things built on top of the Bitcoin blockchain, but they didn't build their own blockchain. They used the Bitcoin blockchain to do this. And what they provide is 2 kinds of object, assets, which could be defined by users, and messages, which really are operations or verbs, so nouns and verbs, if you like. And the Counterparty protocol, which is all scrunched into that frowned upon metadata, or the 80 bytes, which is the right way to do it, it allows you to send things, or provide an order, to pay Bitcoin, to issue an asset, to broadcast messages, to make a bet on something. These are all designed in the current version of it, to pay a dividend for something, to burn or destroy some value, and there are reasons for that. We can maybe talk about that in questions if you're interested, and to cancel a transaction. And then there's the data that goes with that verb, so the particulars of that transaction. This protocol does provide some encryption, ARC4 encryption, and that actually is something that is added on top of Bitcoin. So this is an example of building on top of Bitcoin's blockchain, which you could do with your own apps, and you can build on top of Counterparty. So let's look at a transaction. This is on blockchain.info, and this happens to be a legitimate Bitcoin transaction, but if you look closely, it's got some problem there. It says unable to decode output address. There are those horrendously long string of characters are Bitcoin addresses. One day we won't have them, but for now, they're even worse than email addresses were when people, I don't know if you saw that Today Show thing where they were saying, what's that @ sign? I don't know, what is that? I think it's the internet, you know. Well, we have the same reaction to this. That was in like 93 or something. And blockchain.info can't tell you what it means, but if you look at the script, it says, well, yeah, it's one of those normal ones up the top, and then it's an op return with a big pile of data, and I don't know what that data means. It's strange. So let's go to Blockscan and see what it says. Oh yeah, that is actually someone transacting 1,600 bit crystals. What's a bit crystal? Well, you can look up on using the format that Counterparty provides for people to define assets, and you can see, oh, bit crystals, what is that? Well, it's got it's got some issuance there. It has an image associated and a website. Let's go to the website. Oh, it's something to do with a video game. So some people have made a token that is part of, I don't actually know, I think it may have been part of a crowd sale for funding the video game. It may also be tokens that you can use in the video game. So this is a game. They didn't bother making their own currency and their own exchanges. They just used the ones that were provided to them by Counterparty. And the side effect is that people can transact these tokens for other currencies, mostly cryptocurrencies, but others as well. And they can do that independently of the game. Even if the game collapses, that market can still exist. Now let's talk about Ethereum. Very sexy project. What this provides, is everyone with me so far? So put your hand up if you're a little bit lost. Okay, a little bit lost, right. So I'm just going to recap then. So we're talking about building applications. We're talking about, well, you can build applications on the internet, right? And they can communicate with each other. You don't need to build the internet to do that. The internet already exists for you. In much the same way, the blockchain or various different blockchains, or even the tools to build your own blockchains if you insist, those exist now, and these provide you a new set of capabilities for your applications. So if you want to envisage an application that requires some of those things I was mentioning before, like trust and authority and that sort of stuff, then you can do that on top of blockchains. It's still very early, but here's a technology that allows you to do it, promises or at least suggests a much more broad set of capabilities. Very impressive vision, let's say. It will all depend on how well it turns out. So Ethereum it was a crowd sale. They raised, I don't know what it was, like $17 million US worth of Bitcoin in 24 hours. That's a pretty good run. And that's enabled them to build out their vision. And what it's based on is a Turing complete transaction processing engine. And what that means is anything that can, in principle, be built with software can be built with this. And so the limitations I referred to earlier that Bitcoin has don't carry over in Ethereum. Now, the limits to what you can build that have to do with memory and time and power and all of those limits all exist. But in principle, you can build something with any Turing complete programming language, and you can also build it with any other one. So they are all that you could translate them, because they all provide those same set of base capabilities. And that's one of the most important things that Ethereum is offering. That's much more tricky to do, and there are potential risks with it. Code are known as smart contracts. You've probably heard of smart contracts. I would credit Nick Szabo with being, if not being Satoshi Nakamoto himself, certainly being someone who very early on promoted the use of smart contracts and the idea of smart contracts. And I can't remember if he coined the term himself, but this is a kind of self-executing agreement between parties. These parties may be people, they may be programs. The kinds of account are what's called a normal account, which is something I might have or you might have, or an entity like a company might have. You can create these at will. or a contract account, which is something that is definitely it belongs to a piece of code that is running on that network. And you have a higher level programming language, and I'll show you that. And that ultimately turns into what's called Ethereum virtual machine bytecode. So this is the language of that machine. What is this machine? The Ethereum network is the machine. It is a secure execution engine. It's basically a very slow coin-operated 1970s computer. That's the sort of thing it is. But it's not just a computer, it's actually really a network of computers. And these could exist in anyone's bedroom or in server farms or something like that. So you put all them together and you get the Ethereum virtual machine. That's where the contracts run. They don't run on your phone, they don't run on your computer, they run on that network. With that, and so that's bytecode, the native language of that virtual machine. But that's built from normal programming language. So there's a number of implementations, and this is seen as a healthy thing for the ecosystem to have it built from multiple separate programs. So people have somewhat independently, tried to build the same thing to check that they all work the same way. And on top of that runs a thing called low-level language. Then on top of that, you get a language that you might write a smart contract in. Solidity is one such language. Serpent is another. Serpent actually draws a lot of inspiration from Python. So if you know how to program Python, you might choose to use Serpent to write your smart contracts. And if you like curly braces, you probably choose Solidity. It's a bit like JavaScript. I'll show you some of that code, and you'll see. If you've seen JavaScript, you'll go, oh yeah, I think I know what that is. And so you write your smart contracts on top of that. But one thing I want to say about this is that smart contracts are not magic. They are just software. They do not solve hard AI on their own. So if you just think that this is going to turn into Skynet, well, it does require an evil AI element, which it seems to be not only undesirable, but so far unattainable. Here's an example of a smart contract written in Solidity, which is the JavaScript-y sort of one. You see that you create, where you might create in a language like Java, which is again sort of syntactically similar, you might create a class. In this case, we create a contract. And it has parts to it. Those parts are the sorts of things that application developers might already recognize just by looking at this. And this is the sort of almost the hello world example, which is the typical first program that programmers would write in a new language. And it does provide one other thing, and that is that it can be killed. This contract can be terminated. So it has that additional facility. It says it can say hello to someone. Here's a more complicated contract. Now, we've talked about Bitcoin being a cryptocurrency, and that was written in, say, C++ code by this mysterious Satoshi Nakamoto, and now we have the facilities of Bitcoin. What has happened here with Ethereum is that they've said, all right, we're going to create this machine that doesn't do anything in particular. It does what people want it to do, and it has a blockchain, and we're going to provide these languages which enable people to build stuff. What stuff? Not just hello world. They can build a currency. And this is a very simple currency that allows transactions between parties. And so this is what you need on top of Ethereum to create your own currency, about a page of code. Don't bother doing that. I mean, you can do it. You should do it. Actually, it would be fun. But we don't need more of those things. It should be different. It should be better. But what sort of other cool things do people make? I think these ones are cool. So somebody's made these are called Dapps, by the way. It's a horrible name, but distributed applications. So these are applications running on Ethereum. Just like you have an app on your phone, you have apps on the Ethereum network, or Dapps, if you like. So there's a Dapp store, which is a Dapp itself, and somebody's made a distributed application, which is a marketplace for other distributed applications. Genius. Also, a really important piece of infrastructure for this is a new domain name server system. If you know what DNS is, domain names, IBM.com or whatever, it's a name registration system that works on this network. EtherTweet is kind of like a Twitter thing, but it has 160 characters. Etheria is a sort of Minecraft-like game, which you can mine things, and there's a transactional economy that's built into it. One I like is EtherOpt, which is a binary options exchange built by someone, an anonymous person. I don't know exactly what the regulatory impact of this is, because somebody wrote this contract to enable a marketplace for people to do options trading. And that would normally fall, as far as I know, in the US, that would fall under SEC kind of jurisdiction, and they would have lots of things to say about how such a thing is run. Well, the code is out there, nobody knows who wrote it. It runs on the network, you can't turn it off. What are you going to do? So that's regulator apoplexy there. I mean, they'll have to decide. I don't know who's doing the wrong thing. Is it you and I who run on the Ethereum network, our machines lending our power to the network to sort of run contracts and be paid in this Ether token that is the fuel for the network? Maybe we're doing the wrong thing if we join that network, because we might accidentally be running an options exchange. There's also interesting Studbook, which is Tinder for horses, I'm told. Augur, which is a really cool prediction market. I would love to talk to anyone about that. If you don't know what they are, it's sort of the marketization of anything that you can reliably determine the outcome of. Like where people who are not necessarily friends can agree about the outcome, the true outcome of the world in a binary way, like who won the presidential election, something like that. And, you know, you're going to agree that yes, you were wrong and that person won. So the prediction market enables the market to determine how likely the outcome is beforehand by pricing these outcomes, and you can trade your position, if you like, in that market. It's a fascinating thing. It goes way beyond sports betting. It might also be illegal, I'm not sure. EtherX is a decentralized exchange. This is a common piece of infrastructure that gets built on these things. Wayfund, which is a crowdfunding platform. So there is a sort of financial theme to a lot of this, but you can go quite far beyond the financial products and financial concepts. And AuditDog is an example of that. This is a software audit repository. So if you, like I am, a software developer, there may be, you may need to audit the content of all of the code, all of the libraries and prefab components that you've built this software from, and you may need to know the provenance of all of that, you know, the licenses and what bugs there are and the known vulnerabilities, the security holes, things like that. You can also use it similarly for virus detection and registries. And a cool one I just added after hearing about it this week is Ujo Music, which is Imogen Heap is a fantastic, very creative musician is behind this project to help assist artists or musicians to publish and sell content through a distributed marketplace. So I mentioned AuditDog, which is the software. You don't have to read this, don't even have to take a photo. This is all of the code of the software audit system that AuditDog is. So this is not a lot of code. This is a very small amount of code to provide the sort of facility to allow people to trace the provenance of software components. And the reason why it's so small is because of the level of facility that's provided to you on the Ethereum blockchain and with those APIs. So that's the Ethereum blockchain. What about custom blockchains or private blockchains or permissioned blockchains, permissioned ledgers? We keep hearing about them recently, and mostly because the banks can see how to make money out of them. They say, well, we've got this bad old system. We don't really need this amazing new revolutionary Bitcoin. We could just take a couple of elements out of that and make a less bad old system, and it would be more efficient. And that's what a lot of them are, why a lot of them are excited about it, because there's an impact to the bottom line. And also they don't want to play with the realm of potential criminals and terrorists. You know, don't blame them, but so they would just think, let's just have our own playpen and use this technology among our friends or our frenemies, our other banks. So that's kind of what custom blockchains are about. So if you wanted to make your own custom blockchain, the first thing you should ask yourself is, why do I want to do that? And if it's for fun, then I am with you, but otherwise I would be really questioning whether you maybe should be using one that's already out there. You can use a tool chain. There are some vendors. Eris Industries actually provides free tools for building blockchain systems, and it's based off a fork of Ethereum. And but the case for permissioned ledgers for custom blockchains, I would say, is actually more like you have a partial trust network. They're frenemies. You can trust them to a certain extent. It's not like you don't know who they are. They're all anonymous, and you have no idea whether you can trust them. But actually, I think they're all a bit boring. It's just another distributed database. I'm more interested in what I consider to be the transformative technologies. So I just wanted to bring in a couple of these non-blockchain, but blockchain-era technologies that are often put together with blockchains. And IPFS is a good example. It's called Interplanetary File System. It's kind of like a distributed Dropbox. You network or torrents, BitTorrents, you might know of those. So the data is distributed everywhere and blocks are exchanged between peers, and they build up from that a reliable file system. So a way to store your files, like a big USB stick in the cloud. And storage is another project, a similar idea, that is funded by its own token called Storage Coin, and there's a market rate for that Storage Coin. You can earn Storage Coin by donating your hard drive to store other people's encrypted chunks of whatever. And you can pay in Storage Coin to have your encrypted chunks of whatever stored on that network, rather than paying a company. The goal is efficiency and some, I guess, autonomy. MadeSafe, this is a mind-blowing one. I haven't looked as much into this as the others. This is sort of doing all of that, and the storage, the computation like Ethereum, but also the routing. So the internet has like it's a series of tubes, right? And between those tubes, there's a little router, like you have to go from step to step to step to get to the right place. So you have to navigate through that network. It's called routing. Well, MadeSafe layers on top of the actual internet a whole new network with these features: storage, computation, and routing. And all of those jobs are done by participants on the network. So this range of facilities that would normally be provided, manifest by a network, is provided by this thing running on top. Now, I want to leave time for questions, so I'm going to recap now. Blockchains, that's a new platform for building applications on. Bitcoin is the granddaddy. It's a very general purpose platform. You don't just need to transact money. Counterparty is built on top of that as evidence of this. And Ethereum is a separate blockchain, but with a much broader set of capabilities and even more generic for an application platform. And if you can go beyond blockchains and add some of these other features like IPFS, you can build out quite a sophisticated range of capability. So I guess I'll take questions now. Thank you. Have some resources here too if you want to follow up. Mics?
The microphone is not, I'm sorry. Has anyone built voting applications or other like democracy applications on top of blockchains?
Yeah, the question is, has anyone built voting or democracy kind of applications on blockchains? Yes, and this is a sort of early recognized potential application. In Sydney, a friend of mine's actually building a democratic party called Flux. It's not just a political party, it's also a platform. So I'm not sure exactly what I'm allowed to say about it. I'm not allowed to say about it, but definitely Flux is out there and proposes to pursue that exact goal. And there are other projects, definitely. There may be some significant challenges, though, and maybe we could talk about it later.
Could you talk about a couple of them?
Yeah, you want to make sure that voting is secret, but you want to prove voting has happened. How do you do that with cryptographic primitives? You'd need to be a cryptographer to get that right. Voting has to be secret, for sure. Big problem if it's not. Yeah, it's going to take time. Well, let's just say you're 10 times smarter than me. It's going to take you months. Okay, so it is a very complicated and new thing, even for someone who just spends all their time learning new technologies. So don't let it worry you.
Can you give like a recommendation of somewhere I can start looking for?
Yeah, I really like this guy, Andreas Antonopoulos, is an excellent speaker on the topic, and there's two videos I think really capture Bitcoin and the thing that's happening there. One was Disrupt Athens. It's a very short talk. I think maybe it's 20-something minutes, That's a great, they're all on YouTube. And there's another one where he educated the Canadian Senate on blockchains in the context of regulating cryptocurrencies. And that is a fantastic, I mean, he's pitching it at politicians, not at technical people, and that is amazingly well put together.
Thank you.
All right, I'll just shout. Public versus private blockchains. I'm seeing Microsoft making a lot of noise about doing blockchains as a service. I'm still educating myself. I'm concerned about giving something up by doing a private blockchain versus, say, public, or is there a room for both?
The question is public versus private blockchains. Microsoft, also IBM, other companies are involved in doing things in this space. There is a trade-off. Yesterday, Lisa Ellis spoke quite well about this trade-off in another session about the sort of history of blockchain development, and it's becoming more legitimate. And actually, it's a security trade-off. The Bitcoin blockchain is by far the most secure blockchain because it has the largest network of miners doing the most proof of work, and therefore they have the highest concrete wall as a defense against anyone rewriting the content of the blockchain. If you run a private blockchain, you need to be aware of how hard it is for someone to just come in and rewrite your record. That's what it boils down to. Another question?
I'll just ask here. So, what about enterprises? Like, I mean, a lot of the blockchains is very public-facing and stuff, maybe B2B or B2C. But what internally to like a large multinational, do you see blockchain being useful or applied? If so, how?
Yeah, I think the uses are very broad. Enterprise. The question is about enterprises and how well they would adopt this sort of blockchain technology. There are so many uses for it, not just financial. Mostly they cluster around those topics I listed in that early slide, those things around governance, around auditing, knowing the true identity of things. I keep thinking of where is trust a problem, you know? And obviously in financial systems, the need for trust is high because someone can rip you off so easily. But in other systems as well, knowing that you're really running the right version of that software and it's not some one that's been changed by hackers or something. So there's a lot of information security benefits, and enterprises are probably going to be gaining there. Also, some of those enterprises sell a lot of technology to banks, and there's a lot of noise in this technology industry that this is a kind of technology that that proposes to replace some of those older technologies. And so those big vendors really want to be involved in this technology because they don't want to be left out. Yeah.
What if the blockchain gets compromised? So you mentioned that you can limit publishing to it based on the application's key. I think the application that key that so you can say only certain keys are allowed to publish to this blockchain.
It doesn't limit.
If that key gets compromised, what would you regenerate?
Oh, yeah.
And also, maybe it's the same question. Hashes get compromised. Where people find attached to the SSL. It's not a huge pain, but it's not a huge deal because you can revoke your certificate on your server, make a new one that doesn't have the weak cipher or the weak hash algorithm. Is that the same situation where you have to regenerate the whole?
Yeah, good question. The question is, what about blockchains being compromised? For example, the loss of a key. If you lose your car key, you could lose your car, right? And same for cryptographic hashes. They become, I wouldn't say they don't tend to be broken, completely. If you look at even MD5 and some of the algorithms that we don't use in these, that's not even a cryptographic algorithm, but SHA-1 is a cryptographic algorithm that's a close relative of the SHA-256 one that we use in Bitcoin. And in Ethereum, actually, they use SHA-3. So these cryptographic algorithms that people produce they do wear out over time. They degrade. People find, oh, I found a shortcut to reducing the work I have to do down from 1 billion trillion years longer than the universe will live down to only as long as the universe will live. You know, people find these shortcuts, if you want to think of it like that. But in general, they tend to degrade slowly. The actual algorithms in Bitcoin and even more easily in other cryptocurrencies that anticipate this situation more directly, they can be swapped out without as much disruption as changing other important aspects of the fundamentals. But if you lose your private key, you will lose your Bitcoin. or most likely your other value. So key management becomes a really important thing, and that's a key skill that's actually stopping adoption, especially in corporates, I would say. Key management is going to be this century's fundamental security skill, and all other forms of security will disappear.
Market that needs someone that intermediates trust, right? So banks, Uber, right? So there's someone that's actually validated both sides, right? So how is this? So then you said in the beginning that we're in pre-beta, right? So we're not even mature enough. So are there any technical limitations that we still have to go through to actually have someone actually build an application that can disintermediate and consumer-facing or mass level application?
I think I understand the question. So what are the technical hurdles to actually doing disintermediation and building applications on this platform? There are lots of little ones. So a lot of it's usability, and there are probably bugs. We know, security technologies tend to take a while to become known to be reliable. And that's part of the reason why a lot of Bitcoin's security primitives are actually quite old, made in the 80s, and they've stood the test of time, and that's actually the right way to choose security mechanisms. So there's a certain natural conservatism that comes from the right pace of adoption. But as you can tell, the marketplace for these is sometimes crazy hot, and it will shoot the price of these little instruments right through the roof because they see the potential. So I would say that this room wouldn't have been anywhere near as full if we weren't talking about a self-monetizing system that people could get rich off, because the technology is so early, it would really only still be the geeks who are just thinking about it. But because you can get rich off this, it's brought everyone in, and actually it's better, but also a lot of people who are less familiar with the idea of bleeding edge technology, you're going to bleed. It will take time. It will be awkward and difficult, and the user interfaces are almost universally horrible. So there's one good start.
Many people coming to this session are kind of interested in digital currency like Bitcoin. And from technical perspective, I want to know what are the things you think should happen to digital currency like Bitcoin, so that some official government, like U.S. government, would recognize it, even embrace it in its financial system. And what I'm talking about is a technical aspect, not a political aspect.
The political ones are really interesting, but I'll skip them since you specifically stated that. The technical limitations are integration with all of the systems they already have. So just look at a company. If they wanted to pay, like I sometimes say, yeah, I'll go and do this for you. I'll charge you some Bitcoin, and tell a company, especially a big company, to pay an invoice in Bitcoin, and they just don't know what to do. Not only do they not know how to perform a transaction, but they've got to maintain balances. Where they're going to have someone just random to have it on a wallet on their phone. That's not how they manage their money when it's dollars. They've got accounting software. So people are building accounting software that integrates, and I think I want to say Intuit has a module. Am I right? Yeah, they've got some. So the big name accounting software that people would know are all going to be looking at this and saying, well, if all these companies and governments are going to be using Bitcoin, they're going to need to invoice people, they're going to need to manage balances, and key management, which I mentioned before, is a key part of it. You want to be able to restrict who can pay what, and the capabilities in Bitcoin there are fantastic at that bits and bytes level, but people need user interfaces and practices and processes in their businesses to actually take advantage of those technical capabilities, and those systems haven't been all built out yet. Does that answer your question?
Yeah.
Cool.
Just a quick follow-up question. I believe you mentioned in the beginning that the blockchain is not really good for storage. And then you pointed to the Ethereum apps that actually did have some storage capabilities. How is it?
Yeah.
Is it a reference you store, or can you just perhaps elaborate?
Yeah. The question is, I said that blockchains are not good for storage, and yet it seems that some of those applications in Ethereum do rely heavily on storage, and that's true. A pretty common practice in Ethereum at the moment is to look at IPFS as the storage component, and that's where that purple arrow out of the psychedelic Mickey Mouse I made, that was what that indicated, that you could connect the platform aspect of blockchains to other things which are not strictly blockchain, but which are from that same generation of software. So distributed hash tables, content addressable material. So where you'd hash the content, say you've got a video file or blocks of a video file, you hash that, and then when you want to look it up, you say, I need the file that corresponds to this hash. So you take that flimsy little shadow that I mentioned that can be stored in the blockchain or in your application also, and you say, I need this, number 29. It's not 29, it's going to have a huge number of digits, but I need the block that corresponds to this, and someone can know whether they have that. And that also can be encrypted and distributed and redundantly stored. So generally it will work like that. So storage, IPFS, that's where the storage component will happen. And in MaidSafe's case, I think that they handle all of that.
Since there is no censorship, can you build an app that can fund it, that is unstoppable, like a global smart machine?
You said, since there's no censorship, can you build an app that, what? I didn't catch that part.
It's unstoppable.
Unstoppable.
Yeah.
I would say yes and no. I mean, I don't like to, only the Sith deal in absolutes, right? So you wouldn't, everything's stoppable, really. But it's pretty unstoppable as far as things go. So I'd like to say yes and no to that. And if you're doing something that pisses everyone off on Earth, then they're just going to get together and figure out a way to stop you. But this is what I call marginal activity. If you're competing with some really big incumbents in the industry and they want to use their lobbying leverage to make things difficult for you, then you've got, I would say, you punch above your weight when you use this sort of a system. So it's good for, it's democratizing in that sense. It's good for everyone to play with a bit more of an equal playing field because it's harder to stop things. It is censorship resistant, I would say, rather than censorship proof.
So I understand the utility of blockchain when it comes to consummating transactions between interested parties, but in the enterprise use case, let's say Walmart and its suppliers updating SKU numbers or banks moving balances between each other, what does a blockchain do that an Oracle database cannot?
Yeah. The question, so just slightly, I'll reverse that. What can a blockchain do that an Oracle database cannot? Well, and why would enterprises use blockchains when they've got all these other tools that do things?
And they trust each other already.
And they trust each other, yeah. So first of all, obviously there's many things that an Oracle database does that blockchains do not do, that weren't designed to do them. But there are some things, I mean, you say they trust each other already. Does every, casual employee have the keys to the safe and all these big companies? No. They don't all completely trust each other with their lives, and the keys to the kingdom, do they? Trust is a grade. So they don't even, and companies get ripped off by their senior, their financial people all the time. Someone embezzles money from this and that. I mean, you can't open a financial newspaper without reading a story like that. So they all don't trust each other to some extent. And so it's that management of a trust level. And how do they prevent that? Well, they get insurance, which turns trust into a cost. They get checks and balances. They have multiple parties involved. And now you're starting to talk in terms of a process that actually can be rendered into the transaction language I was describing. So if you want to run in your company, the rules of people are allowed a certain budget and they're allowed to spend that without triggering this need for some oversight. I mean, this is how companies are managed. So I'd say governance within a company is actually going to be a lot better with blockchains than it is currently in many of those companies. Now, can Oracle do that? Yeah, they can use the same technology. This is open source. I mean, in some ways, it's just a distributed database. But in the Bitcoin's case, they've cranked all the knobs to 11 and they have a system where they said, we don't trust anyone. We don't need to know anyone. So therefore, we know we need the most security and we know that we have it because if we didn't, everyone would have been ripped off by now. So it's a question of levels. But you could also say that Walmart and all these big companies, they don't need the full capabilities of TCP/IP, they just need to send email, or they just need to do this or that. And that was the argument about the internet earlier on. They don't need this whole thing. But once everybody gets on the network and everybody's using the internet, then it's just easier because all your devices know how to do that. And even if you don't use most of the capabilities, it becomes a commodity platform. And that's what I'm describing here with these blockchains. We're a little early to call winners and losers, and maybe there will be multiple blockchains. I mean, certainly there would be. And but this sort of technology is going to favor the applications where trust is harder.
Well, obviously, Bitcoin has run into two big problems over the last 1 or 2 years. One is the scalability issue, and the other one was that only a few miners control much of the network. And as far as I understand it, some rivaling teams have tried to solve that problem, and that has brought an even bigger problem to Bitcoin because now we have a forked core. Is that correct? And my question is, do you think that the problem will be solved with a Bitcoin, or will there be another protocol that will replace Bitcoin and have the same but better capabilities?
I'll take them in reverse order. So the second question was, do I think there'll be another rival to Bitcoin with the same but better capabilities that will replace Bitcoin? I actually don't feel confident to answer that question. I can't really predict what will happen in that way. I think that we could guess how that could happen, and I think the largest potential cause of that would be systemic failure in the development team to continually release quality updates and capability to the system to maintain its stability and future capability. So that could cause Bitcoin to degrade in, I would argue, the same way as MySpace did, in favor of another network effect dominated system. So Facebook was better at doing what MySpace did, basically. And so but when you have a network, I have to wrap up, so we can go outside and chat. But when you have a network effect dominated marketplace, one like currency would be particularly a network effect dominated. It makes it a lot harder to dislodge someone who's winning by having a big network. And the first question you asked was, I've forgotten, what was it? It was about, oh yeah, the trouble in Bitcoin. Yeah, so the fork isn't really a problem. This sort of happens in open source. That's my quick answer. We should expect this. Yes, it feels a little bit unstable to a lot of people, but it's just part of the process, put it that way. It's a little like families, families get messy sometimes. The other part you said was, oh yeah,
So you're still confident that
Bitcoin's the one. I don't really like saying Bitcoin's the one and nothing else will come. I don't like saying that. I mean, I really like the look of Ethereum, but they have set a massive, courageous target, which is to build this amazing system that does much more than what Bitcoin was intending to do. Oh yeah, one point to note is that this is all open source. So if someone else comes along with another open source project that's sort of 20% better than Bitcoin, Bitcoin can just say, well, you know what, we'll use that stuff too. And we've got the network, and now everyone can use that feature here. And why wouldn't they? Why were these guys doing it by themselves in the first place? Anyone can make their own Bitcoin client. I say officially, there's no official Bitcoin core group. That's just what they say. This is open source. I think we're done. Thank you. That's a wrap for another episode of Atlassian Tech TV. Please subscribe and follow us on Twitter. We've also got tons of stuff on our blog at developer.atlassian.com.